All right, if you're working with React, you know the drill. Performance is king. A slow app, it's a total engagement killer. So today, we're going to break down two super powerful, built-in techniques to make your apps feel lightning fast. We're talking about code splitting and lazy loading. Let's dive right in.
So, get this. What if I told you that you could slash your page load time by up to 40%? I mean, seriously, and that's not just some number I pulled out of a hat. This comes from actual research, and it shows just how massive the performance gains can be when you use the strategies we're about to cover. We're talking a complete game changer for your user experience.
Okay, so to get those incredible results, we've got to pinpoint the villain here. What's really slowing our apps down, especially our React apps? What makes them so sluggish sometimes? Well, it usually boils down to one single core problem.
And that problem, we'll call it the heavy bundle problem. Yep, this is the main culprit, the big bad villain behind those painfully slow initial load times.
So what exactly is a bundle? Well, think about it like this. When you build your app, tools like Webpack basically go through all your code, every single component, every library you've imported, and cram it all into one giant JavaScript file. It's convenient for development for sure, but it creates a huge issue. It means your users have to download the entire app, the whole shebang, just to see the homepage, even the code for features they might never, ever click on.
And why does this matter so much? Well, the stakes are super high. We're talking real-world impact. Research shows that just a 1-second delay can drop your conversions by 7%. Plus, Google will literally penalize you in search rankings for being slow. And think about your users on their phones, maybe with a spotty connection. For them, that heavy bundle can make your app feel completely broken.
So how do we fight this heavy bundle monster? The strategy is actually pretty simple in concept. Instead of shipping that one giant box of code, we're going to break it up into a bunch of smaller packages. And then we only send the user exactly what they need right when they need it.
And this awesome strategy has a name: code splitting. It's a feature that's already built into modern bundlers. It lets them create these multiple smaller bundles, we call them chunks, that can be loaded on the fly dynamically whenever the user actually asks for them.
And you know what's crazy? The way you tell the bundler to do this is incredibly simple. Look at this. On the left, that's your typical everyday static import. But on the right, that's the magic. It's a dynamic import function. Just by switching to that syntax, you're basically sending a signal to your bundler saying, hey, don't put this code in the main bundle, make a separate little file for it.
Okay, that's cool for the bundler, but how do we handle this inside of React itself, right? This is where our two heroes enter the scene, React.Lazy and Suspense. These are the incredible tools React gives us to make this whole code splitting thing practically effortless.
So first up, we have React.Lazy. It's a function, and what it does is it takes one of those dynamic import calls and wraps it up so it looks and acts just like a regular React component. It's basically the bridge that connects the bundler's code splitting magic to your React app.
But that brings up a really important question, doesn't it? When a user needs that component, the code has to be fetched over the network. That takes time, even if it's just a moment. So what happens in that gap? We can't just show a blank screen or a janky, broken page. We need something.
And that something is Suspense. It's the other half of our dynamic duo. Think of it like a safety net. You just wrap your lazy component inside of Suspense and you give it a fallback. That fallback can be anything: a loading spinner, a cool skeleton screen, whatever you want. Suspense is smart enough to automatically show that fallback UI whenever the component inside it isn't ready to render yet.
So let's walk through how this beautiful partnership works. Step 1. React hits your lazy component, and that kicks off a network request to grab the code. Step 2. Instantly, the Suspense component wrapping it says, "Whoa, not ready yet," and shows your loading fallback. Step 3. The code arrives from the network. And finally, Step 4. Suspense automatically and seamlessly swaps out that loading indicator for your fully loaded component. It's this perfect, elegant little dance.
All right, so that's the theory. It sounds great, right? But where do we actually use this stuff in a real-world app? Where do you get the most bang for your buck?
Well, the React docs themselves give us the best advice here. The number one place to start is with your routes. It just makes so much sense, right? People are already used to a tiny pause when they click a link to go to a new page. It's the most natural boundary to split your code on, and it's the perfect place to load things on demand without the user even really noticing. And here's what that looks like with a library like React Router. It's super straightforward. You see, instead of importing the homepage and about page normally, we wrap them in React.Lazy. Then we wrap our whole routes component in Suspense with a fallback. Now the code for the About page won't even be downloaded until someone actually tries to navigate there. It's awesome. Oh, and one quick pro tip here. This is important. What happens if the network is down and the code for that About page just fails to load? Well, the standard practice is to wrap your suspense component in something called an error boundary. That way, you can catch the loading error and show a nice message instead of, your entire app crashing.
Okay, so we've covered the how and the why, but now for the big payoff. What's the actual, measurable difference this makes? Let's look at the numbers.
So check this out. This is the hard data from that study we mentioned, and the results are just wow. First Contentful Paint, that's how fast something appears on screen, dropped by a whole second. The total JS bundle size was cut by 600 kilobytes. That's huge! But the number that really blows my mind is the time to interactive.
Time to interactive, or TTI, is maybe the most important metric. It's the moment when the user can actually click on stuff and use your app. And by doing this, the TTI dropped from a pretty frustrating 6.5 seconds all the way down to 3.8 seconds. That is a night and day difference that your users will absolutely feel.
So, where do you start? Here's your action plan, your checklist. Number 1, routes. Always start with routes. It's the easiest and gives you the biggest win. Number 2, look for things that only show up when a user clicks something, like a big complex modal or a pop-up. Lazy load that. And number 3, anything that's below the fold, content the user has to scroll to see, is another perfect candidate for lazy loading.
Look, by shipping less code up front, you've already made a gigantic leap forward in your app's performance. But optimization is never really done, is it? It's a journey. So the real question I want to leave you with is this. Now that you've crushed your initial load time, what's the next bottleneck you're going to hunt down and fix?